All right, so here's the problem. Now go ahead and pause and solve it. All right, so the question says which of the following would have the highest energy photons? Now, a couple of different ways you can kind of think of this or approach this, but fundamentally it's going to require you to understand how the electromagnetic spectrum works, right? So electromagnetic spectrum goes in terms of things with low frequency, to things with a high frequency, right? So high frequency. And from this standpoint, we first have to think about which one would have higher energy. Is a low frequency going to have higher energy or a high frequency, right? Now, there are a couple ways you can think about this. You can think about this in terms of the equation, energy equals h, which is a constant, times frequency, right? So in this case, frequency is going to be directly correlated with energy, right? So in this case, from the equation, we understand that a higher frequency is going to equal more energy. We can also think about this just in terms of kind of the intuitive sense that I've explained before, where a wave that looks like this is going to be carrying less energy. It's going to kind of pack less of a punch than a wave that looks like this, right? That's a terrible looking wave, but you understand the point. And so from just kind of an intuitive sense, from a sense of understanding how, how waves are carrying energy, we know that a higher frequency is going to be higher energy. So high energy, high E, high, and we do capital because energy is typically drawn as a capital. All right, so now we have to understand which way the rainbow goes, right? So, of course, the electromagnetic spectrum includes various different things, and visible light is one element of the EM spectrum. And let me go ahead and make the pen a little bit smaller so I can kind of draw, right? So there are different things happening. And then let's say this is visible light, right? Visible light. Right. Now, again, there are a couple of different ways you can kind of remember the order of visible light, right? You should, hopefully you understand Roy G. Biv. Roy G. Biv. This is the order of the rainbow. But which way has higher energy, right? So which way are we dealing with higher energy? Which way are we dealing with lower energy? And I just realized I wrote high energy for both. So let me fix that. Low energy. So one way that I always remember this is I know that infrared light has lower energy. That's just that's something I've kind of memorized, right? I never think of infrared in terms of it being dangerous. I think of it in terms of imaging, using infrared, things like that, right? So that's how I know that infrared has lower energy. Infrared. And then, of course, so if it's infrared, then the next one in terms of visible light is going to be red, right? So once we get to visible light, it's going to be red. And then we get Roy G. Biv, right? So Roy G. Biv. And then, of course, higher energy. And so the last one is, in terms of highest energy, visible light is violet. And then after that, of course, is going to be ultraviolet. Ultraviolet. And I know that ultraviolet, that UV is higher energy. And I think of that because it's pretty dangerous, right? I mean, not super dangerous. It's not like gamma or X-rays, but it's not particularly safe, right? We understand that when we go out in the sun, it can be dangerous. So I always think of it in terms of, I know that infrared is pretty safe. I don't really think of it as a dangerous thing. So it's kind of lower energy at least than visible light. And then I think of ultraviolet as, oh wow, ultraviolet, you have to be careful about that, right? And so I think of that in terms of being higher energy than visible light. And so of course, in the middle, you've got the colors. So infrared, then you get to red, ultraviolet, then you get to violet, right? So I think it's fairly straightforward there. So the correct answer here, of course, is going to be violet. But there is no violet in the answer choices. So we have to go down this way, right? We have to go down the rainbow in reverse order. So violet is the highest energy. Next we get indigo. And of course, indigo is not here either. And then we get to blue. So the correct answer here is blue. Blue is the highest energy, right? Blue light has the highest frequency. So blue light is going to look kind of like this, let's say, whereas red light is going to look more like this, right? And that's obviously an exaggeration, but you understand the point. And so correct answer here is B, that blue light has the highest energy photons, and red light, of course, is going to have the lowest energy photons. And so, again, it goes in order. Red light has the lowest, then Roy G. Biv, right? Roy G. Biv. Anyway, so the correct answer here is B.